Okay guys, so today we're going to add two vectors together. We're going to keep it very, very simple. We're going to add two vectors together and find the angle. So let's just go crazy. Let's make this one right here. And then let's just take another one and let's go green. Oh, sorry. And we're going to add it right here. So you can see, now these vectors, we could define these vectors by their points right here. So this one is 1, 2, 3, -3, comma, 1, 2, +2. And this one would be +3, or +2, +3, so it would be 2, comma, 3. And then if we were going to add these together, we could get the resultant. We could move them, or we could just add them together. So hopefully you guys at home are doing this real fast, and you say, okay, so if I wanted to find the resultant, it'd be -3 + 2, and that's going to give me -1, and then it's going to be 2 + 3, which is going to give me 5. And I just added my x's and my y's, and that's how I got this. Let me make a little dash. There we go. That looks more like 5. Now, we could also visually add these together. And you guys have experimented with this. You move it around, and we'll see we'll quickly go off our scale. But when we scroll up here, you'll see, wow, well, if I count that 1, 2, 3, 4, 5, I'm going to get -1, comma, 5 as my answer. Okay? So, what you would quickly say then is that I get a resultant that looks something like this, and this would be your resultant. Okay, now a lot of us are having problems though finding the angle of the resultant. So let's simplify our space real quick. Let's just say, okay, we've got a resultant. This is gone. You're 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 gone. Okay, so we've just got a resultant. How do we find the angle of that? Well, the angle is going to be this. It starts here at 0. It's going to go around here. Now remember, this is 0 degrees, guys. This is 90 degrees. And this is 180 degrees. Okay, so those are going to be our 3 angles. In fact, if we wanted to keep going around, we could go, and we'll get to maybe I'll do another sample problem where we do something that's down here in 270 realm, and one over here in 360. Okay, so we could do this any number of ways, guys. But the one thing we should realize is that these coordinates up here, what they are is they tell us the point for this, and this is going to actually make a triangle. If you really wanted to think of this in a simplified way, you could say that this, what that point is telling you is that it's saying this part of the triangle, this one right here, well, that is 5, and this one is in fact 1. This is a 5 by 1 is your 2 sides for your triangle. This side's 5, and this side is 1. So that's going to be your sides, and to find the results, and you just simply do the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, and I think we can do that real quick. If we call this a, and we call this b, it's not coming out so well, but you heard me. So we have 5 squared, which is 25, plus 1 squared, which is 1, equals c squared. And then we just quickly get c is the square root of 26. Okay, and that would tell you the length of this resultant. But once again, it's a vector, and a vector has to have an angle. So how can we get that angle? Well, it's not too bad. Now we can see we have this angle right here. Do you guys see that? This angle right here. Now, this angle is with respect to the negative x-axis. That's a major no-no for our recording. But when we take this, we can say, well, this whole thing right here, that's 180. And this is going to be this angle less than 180. And we can easily subtract that and get the right answer. So let's practice this, guys. Now, we see that we have this side, which is 1, and this side, which is 5. This is our opposite. This is our adjacent. We can easily use tan. Tan theta equals opposite over adjacent, which is going to be tan theta equals 5. Okay, so we've got 5. And then we're just going to go theta equals inverse tan. Remember, guys, use your inverse tan, -1, 5. Okay, now give me 1 second. I'm going to run to my book bag and get my calculator. Okay, I'm back. And I'm going to take my calculator out. Oh, thanks, guys. And I'm going to go second tan 5 and enter. And I should get about 78 degrees for this. 78 degrees. Now, are we done? No, we are not. Theta equals 78 degrees. And the first hint that we are not done is that you should know, just by looking at our diagram, that 78 degrees should be over here. It should be in the first quadrant. Okay, so remember what we said, guys. This angle that I actually calculated is right before. It's an angle that touches my vector and goes to 180 degrees. It's actually 78 degrees before 180 degrees. So I'm just going to subtract. I am 78 before 180 degrees. I got to go 180 minus 78. I'm sorry. Degrees is going to give me 102 degrees. And that will tell me the angle of this vector. Okay. Now, let's give you guys what you've been coming here for, the bonus problems. Okay? So, let's undo everything. Go away, go away. Come back, go away. Okay, so here we are. What I want you to do, take this vector, and then I'm going to come over here. I want you to take this vector. Let's make it like this. Okay. The first thing I want you to do, I want you to find the magnitude of the resultant. Up. Control Z. Sorry. I'm trying to write and I'm not in that. I want you to find the magnitude of the resultant and also find the angle of the resultant. So, two things to do. For this, these two vectors right here, add them together, find the magnitude, and find the angle. Okay.